Okay, so for this problem, what we need to do is we need to see whether f of x equals 2x squared minus 3x minus 1 is continuous at that point x equals 2. We need to justify using the continuity test. Now, logically, you guys may look at this and go, it's a quadratic, it's a parabola. Yes, it's continuous. We now want to prove. So the way we're going to prove is we're going to be following those steps that we were looking at in the beginning part of the lesson. So the first step we need to prove is, does f of 2 exist? How we're going to do that? We're just going to plug in 2 for x and see if a y value exists from that. So f of 2 equals 2 times 2 squared minus 3 times 2 minus 1. That's 4, 8 minus 6 minus 1. And that gives us 1. So yes, in fact, it does exist, so it passes step 1. Now, if it fails step 1, we still need to obviously keep going. There's different steps, but the next piece we need to cover is we need to prove that, give me a second, for some reason this is not, here we go. We need to now just prove that the limit exists as x is approaching 2. So what we need to do is we need to get the calculators out and look at the values in your calculators. You looked at that video. Is you need to look at it as x approaches 2 from the negative side and as x approaches 2 from the positive side. So smaller than 2 and then greater than 2. So once you go ahead and you do that, you should see that you get something like this in your table, where the points as x is getting closer and closer to 2 from the smaller side is approaching 1. It's getting closer to 1. And then as it's coming from the larger side, it's getting smaller, but it is also getting closer to 1. So since they are going to the same point from both ends, yes, the limit at that point does exist. And we can then determine, because it passed 1 and 2, and that it is all going to that same point, we can say that the limit as x approaches 2 for the function does in fact equal that function of having 2 plugged in it. Because what this third step has to define is that we could also have, you know, our graph approaching one thing, and it could be a hole, and it could be an answer down here. So that would be like a removable discontinuity if it was that case. So it could pass the first and the second. Oops, sorry about that. So we can then look at it and say, yes, the limit does exist for this function as x approaches 2, and that is f of 2. And then you can go ahead and take a peek at that graph and see that it in fact does exist at 2, 1, and the sides approach that value as x is approaching 2 from both ends. And that is an example.